Yeah, so thus far, we've always had a positive number inside the square root. We knew that because of the graph of a square root function. There are no negative x values. It always starts at 0 and goes to infinity. That's my domain.
Mhm.
And now the question is, what happens if I put a negative inside the square root? So the rule here is this, is that whenever you see a negative inside a square root, we take out that negative out of the square root and put an I in its place, in front,
An I.
an I. I stands for imaginary. Now, the way this works in our equation is -4 is actually made up of -1 times 4. So now we can split those up. We have square root of -1, square root of 4.
Hmm.
We know that square root of 1 now is I, and the square root of 4 is 2. So the answer is 2I. All right. So, okay, so if we had square root of -8, okay, so if we had square root of -8, we know 8 is made up of 4 times 2,
Mhm.
and 4 is 2 times 2. So, and then the negative out in front of it. So it's -1 times 2 times 2 times 2.
Do you use the least number? The least like
Well,
the number
I
two?
break it down to its smallest possible. But I'm
Okay,
looking for, because it's a square root, I'm looking for a pair of numbers.
gotcha.
So, for example, square root of 4 is made up of 2 times 2.
Two
Once I
times
have a
two.
pair of numbers, it comes out
Gotcha.
as a 2.
Gotcha.
So since I have a pair of 2's right here, those 2 comes out. So I have a 2 square root of -1 times 2. Now, since we have a -1 in there, what happens to that?
And it comes out, wouldn't it?
It comes out as an I.
Gotcha.
And there's your final answer. So the square root of -8 is actually 2I radical 2.
Radical two. Gotcha. Because it like you've always explained before that there could never be a negative in the square root itself, right?
Exactly right.
Okay.
As okay, well, in the even roots, because we could have square root of 4, we
Mhm.
could have fourth root of 16, you can have a sixth root. If the root, remember these are called the roots.
Roots, right?
If the roots are even, you cannot have negative inside there. So if the root is even, then you cannot have a negative inside.
Gotcha.
If you do, it becomes an I. And the size of the I will determine later on, because they're with I's,
Mhm.
One of the rules are i's cannot have exponents. That's one of the rules, and we're going to talk about that at the end of this section on how to get rid of all the exponents on I.
Okay.
So if the roots are even, you cannot have a negative number side. If the root is odd, like the cube root, the fifth root, the
Gotcha.
ninth root, it can
9.
be positive or negative.
Gotcha.
The reason for this, let's look at, that's right. Can you see that there?
Yeah, I can see.
Tell me when you're done. I'll go to the next page.
Gotcha.
For example, so if I had the cube root of 8 versus the cube root of negative 8. Eight is made up of 4 times 2, 2 times 2. So it breaks down to 2 times 2 times 2.
Hmm.
Since there's 3 of them, that's how many I need. The answer is 2. Because this root tells me how many of a kind do I need to take it out.
2. Wait, 3. There's
3.
2 times 2 times 2.
Yeah, because it's a cube root. The root tells me how many I need to pull it out. So if
Oh,
I had
okay. I see what you, oh, okay. It's clicking now.
if that
It's
was a
gonna be
fifth root, I'd need 5 of a kind.
5 of those.
Right.
Yes. Okay. Got it.
Now, the negative inside there, since we know it breaks down to 2 times 2, it can break down to negative 2 times negative 2 times negative 2.
Mhm.
Because if you have an odd set of numbers, it can be negative. Negative times negative times negative is negative.
Right.
2 times 2 times 2 is 8. So the answer here is negative 2.
It's negative 2. Oh, yeah. Wait. It's negative 2.
That's the answer. Because if you have an odd root, that means you have an odd set of numbers.
Right.
And they all have to be the same. A negative times negative is a
Positive.
positive. A positive times a negative
Times
is
a
a
negative is a
negative.
negative.
So,
Got it. Okay.
and that's why it only works on odd numbers. Also,
Gotcha.
let's look at the graphs of our functions. The square root looks like that.
Mm-hmm.
The cube root looks like this.
Gotcha.
So you can use positive x's or you can use negative x's. They both work.
Positive or negative.
So far, so good?
Yep.
All right. Now, let's define a complex number. Which is kind of a misnomer because it's not really a single number, it's a pair of numbers. A complex number has this form. A plus bi, where the A represents the real numbers and the B represents the imaginary numbers. And A and B belong in the set of real numbers. So that's what A and B are elements of the real numbers. So they belong to the real numbers. Remember what real numbers are?
Not off the top of my head, like you're talking about like positive.
Well, it's anything between negative and positive infinities. Anything
Okay,
between there.
gotcha.
So for example, that's a complex number. 3 plus 5i. Negative 2 minus 6i. That's a complex number. Three is a complex number. Negative 2i is a complex number.
Have a great day. Yes, I did. Thank you. Yes, ma'am. Thank you. Thank you. You have a great one. Sorry, I'm in class.
Now, why are these two complex numbers?
Because they're wait, no. I almost said real numbers. Just kidding.
Remember, because complex numbers have to have this form.
Right. Is it no, I'm guessing at this point. Never mind. No, I'm not gonna guess.
Well, remember, A and B are anywhere between positive and negative infinity.
Right.
Do we have an imaginary number?
Plus 0.
Plus 0i, right? Likewise, this one. It's 0
Right.
plus
0i.
0 minus 2i.
Gotcha.
Is I an imaginary number or complex number?
Yes.
Okay.
Wouldn't you? Well, because I would think because 0 plus 0, but I.
Yeah, but 0 times I is 0. So is it complex?
It's an imaginary number. I don't know.
What number's in front of I?
1.
A 1. So is the real number 0? Imaginary B is 1.
Gotcha.
Which we have to know this. For example, let's say we had 3. No, say 6 plus 3i. Divided by 2. As opposed to 2 plus 2i over 2. Can you simplify those?
It'd be 9i over 9i over 2, and then the other one would be 4.
You
No?
can't combine those. Are they like terms?
Oh no, you can't
No,
because
you can't.
one a whole number and the other one has imaginary. Got it.
Right.
No.
One's real, one's imaginary. So you can't combine them. But
Right.
can you simplify it?
I'm saying like with like the 6 into 2, you can 2 into 6 and then 2 into 2. Can you simplify that?
Let's
No.
see. Let's see. Hold on. Let's
Right.
prove that. So if we had 4 plus 5i divided by 4.
4 plus 5i. Okay.
Yeah. Oh, let's just do 4 plus for the i's right now. Let's do real numbers.
Okay, real numbers.
So what you're saying is I could cancel this 4 and that 4.
Right.
But what does 4 plus 5 equal?
9.
9 over 4.
9 over 4.
But if I cancel those, what do I get?
You cancel them and it'll be 5.
Oh, and everybody falls for that. When you cancel something, how many times is 4 going to 4?
2.
How many times? 4 goes into
I
4.
mean, one. I was counting the twos in my head already. I was like 2 plus 2, but no, it's 1.
So you'd end up with 6. Is 6 the same thing as 9 over 4?
Wait, say that one again.
Is 6 the same? Because if you cancel the 4s, you'd have a 1 left over.
1 left over. 1 plus 5,
Is 6.
6.
Is that the same? Are these the same numbers?
No,
So which ones are wrong?
the 6.
Yes. Because where did this come from? The way it comes from is if you have the same denominator, that's where it came from. So if you're going to cancel something, it has to be able to go out of both of those things.
Right.
Because the number on top is one solid number. Same with these. I can't cancel the 6 and the 2 because it came from this.
Gotcha.
So what I can do though is, oh, instead of a 2, let's make it a 3 on the bottom. Make it easy for us.
Okay.
So what does the top have in common? Remember, it's one number.
One. Wait.
Yeah,
Like.
whenever you have a numerator denominator, if it has a plus or minus,
Mhm.
put parentheses on those numbers because they belong together. They have to stay
Okay.
together. So what 6 plus 3i, what do they have in common?
Numbers.
What numbers?
The 6 plus 3, but you say we can't combine them, right?
Right. What is 6 made up of?
Oh, 6 is made up of 3, 2 times.
2 times 3. Now what do they, so now what do these two numbers have in common?
3.
A 3. So I can factor out a 3.
Right.
If I factor out a 3, what do I have left? I took out a
2.
3, so I have a 2, plus I took out a 3, I.
Oh shoot.
Now, since this top number is multiplied, now you can cancel.
Oh, that's where the whole step of messing up happens.
Well, think of it this way. 8
Mhm.
divided by 2. Well, we know it's 4, but why is it 4? Because 8 is made up of 2 times 4.
Right.
Now I can cancel the 2's. Only when you multiply can you just cancel one of the numbers. When you're adding and
Oh,
subtracting, it has to be through both of them. So the final answer is 2
oh,
plus I.
gotcha. 2 plus I. And then so it's only we could only take away with
Yeah, you can only cancel if it's
only
multiplied together.
cancel during multiplication. All right, got that. Got that.
All right, so let's do
Right.
the other one. So since we know that rule now, what can we do on top? What do we have?
So it's okay. So it'll be 2 times 1.
Okay, yeah, it's 2 times 1. So what do they both have in
Right.
common?
2,
So,
obviously.
yeah, we'll take out a 2. We end with what?
And then we end with 2i. No, 1i. That's right. I'm a little confused now. It's a little simplified.
Well, no,
1i.
like you did, when you split these up, 2 times 1, you factor out a 2. So we take out a 2.
So it took out the 2, and then you have the 1 left over
1 plus I, right?
plus I. Okay, and it's over 2, right? So
Yeah.
then 2
The
divided
2's
by
can
2,
cancel,
and there'll be 1 plus I.
right?
Um,
And there's your answer.
Doesn't seem that hard right now.
No. Well, the easiest way is whenever you do something like that, let me see. If I had 18 minus 24i,
Okay.
I say I want to divide it by 12. So let me show you the easiest way when once you figure out what they both have in common. So let's see what they have in common. 18 breaks down to 2 plus 9, or 2 times 9.
Mm-hmm.
9 is 3 times 3.
3 times 3.
24 is 4 times 6.
And then 2 times 2, and then 2 and 3.
Right. So what do they have in common?
They have 2 and 3. So there's 3 3s and then
No,
3
no, no.
2s.
You have to get, these are both separate numbers. So it's
Oh,
2
okay, yeah.
times 3 times 3 minus 2 times 2 times 2 times 3i.
Gotcha. So wait, because I can't, let me move this out the way. So, oh, okay, so we do one number versus the other side, right?
Yeah, so they both have,
Gotcha.
we take out 1, 2.
2 times 3 times 3 minus 2 times 2 times 2 times 3.
Right.
Gotcha. All
Times
right.
I. So since they both have a 2 in common, I can take out 1, 2. And they both have 1, 3 in common, so I can take out a 3.
Gotcha. And then
So what are we left inside there?
was this 3? There's 3 and 2 and 2.
Well, it's because of that minus, they're two separate equations. What does that one have?
3.
Just a 3, right? Minus, now what does the second one have?
2 times 2.
Which is
I mean 4.
4i, right?
Over 12.
So in the front, we have 2 times 3, which is
6.
6. And inside the parentheses, 3 minus 4i over 12. Now what can cancel?
What if it cancel? Like the 6 and the 12, you could simplify it, right?
Right.
Or
If you simplify it, what do you get left?
I would think 1 6, but my brain isn't always right.
Well, 6 goes into 6 once. 6
Right.
goes into 12
2 times.
2 times.
I mean, yeah, 1 2.
So since that's the 1, we don't need it anymore. It's gone. So on top, we have 3 minus 4i over 2. There's your answer.
Oh, okay, gotcha. Okay, that breakdown, it takes a lot of patience and working out a breakdown.
But there's also a shortcut. Okay, since with practice, we know what 24 and 18 have in common.
Right.
They both have a 6 in common. So we take out a 6. Now to figure out what goes inside the parentheses, whatever you factored out, divide those. So 18 divided by 6, 24 divided by 6i. Whatever you factored out, divide whatever's inside the parentheses, and whatever's left is your answer.
So, okay.
18 divided by 6 is
3.
24 divided by 6.
4.
Yep. See, that's exactly
Oh,
where we are here. And we skipped these two bigger steps on top. So
gotcha.
whenever you factor something out, put the remainder inside parentheses and divide each part by that number.
Gotcha. So that's what we did. So I divided it and it was whatever this was is out. And then that goes into there.
Okay, how about this one? What can you factor out of here?
Like 3 plus 12i equals. So 3 into 2, like, are you asking how many 3's can put into
Well,
12?
no, first off, what do they both have in common?
3.
Yeah, so we have a 3 in common. So now whatever goes inside the parentheses, you take those two numbers, 3 plus 12i, and divide them by what you factored out.
3.
Mhm. 3 goes into 3 how many times?
1,
12 divided by 3?
4, 4.
Yeah, 4i. That's how you could figure out what goes inside the parentheses.
Gotcha. Gotcha. That doesn't seem as hard as I make it seem.
No, with
I
practice again.
overthink a lot. Yeah,
Oh yeah, just when you say math, people overthink it.
I
Okay,
do.
so now let's look at the algebra of complex numbers. The algebra of complex numbers. Whenever we say algebra of, all that means is addition, subtraction, multiplication, and division. So let's look at the addition and subtraction of complex numbers. Before we go any further, I forgot to mention one little thing here.
Okay.
Typically, we don't like to have negatives in the first term.
Right.
So what we do, when we ask what we factor out of here, they both have a 4 in common, right? But we
Mm-hmm.
also get rid of the negative. So we factor out a -4.
So you can actually bring it over?
Right.
Okay.
Because remember, each of these numbers are made up of positives and negatives anyway.
Right.
So
So it'll be
inside
like
here,
1,
yeah, okay, it'd be 1.
and then wait. It's 2 4s. So to make it 8, right? Am I doing this right?
Right. Right.
So I would say plus 4.
Okay, we factored out a -4, right?
All right.
Remember what we said earlier? So whenever you factor something out,
Mm-hmm.
to determine what goes inside there, divide by what you factored out.
Right.
Since I
-4.
factored out a -4, I divide each one by -4.
Oh, got it. 2. Got it.
A little bit more than that. You're close to it. So the first one,
Negative.
negative and negative cancel. 4 divided by 4 is 1. A positive divided by a negative is a negative.
-2.
-2i. Don't forget the I because it's
I.
imaginary.
Right.
So
Gotcha. So
basically
it's
what
a
happens, whenever you factor out a negative, it changes the signs of
the
both numbers
sign
inside there.
inside. It
Yeah, so
also changed the number inside too, right?
well, actually, we could have done it two ways. Remember, I
Mhm.
try to preach do the signs and numbers separately. We
Mhm.
could have let's first take out the negative.
Okay.
So that changes the signs of both numbers inside there.
Okay, so you negative 4 minus 8i.
So since I took out the negative, this -4 became a +4, this +8 became a -8. So now what number do they both have in common? They both have a 4 in common.
Right.
To get the same answer. So if you do it this way, take out the sign first,
Mm-hmm.
change everything inside the parentheses, and then take out the number. You never have to worry about positives or negatives again.
I see. I see what you're talking. I see
So
what
yeah,
you're doing.
I
I feel
factor
like I have
out
to.
the negative first. I get that. Then I factor out the number, the common number.
Gotcha.
Because yeah, the biggest mistake students have is when they do the factoring with negatives is they change everything wrong.
Yep.
So if you treat them both separately, you'll never go wrong that way.
Gotcha.
So I forgot to put that in there earlier. Because negatives always throw people off.
Throws me off every time. I'm that
Exactly.
person.
So if you treat them separately than the numbers, you'll never go. It would diminish the number of errors you make because of that. Yeah, you said the test you took because of negative sign.
Yeah, that was me.
Try it again. Start practicing doing them separately. If you notice, whenever
Okay.
I do foiling, I always do positive times negative, then the number times number. I always do the
Right.
signs first.
Yes.
One rule for adding and subtracting complex numbers. Combine like terms. After removing parentheses.
Parentheses.
Because when you're given a question, you'll have something like this.
Hold on, give me 1 second. Hello, gentlemen. Hello, gentlemen. How you doing today?
Inside the door.
Yes.
Not working.
The very first one? Okay, let me write that down.
It's so
Right.
crazy. It's
Okay, so first bicycle.
hopefully you're not there. It says, are you there? Are you there? They can't tell if you're there.
Oh, it does the pet. So sorry.
All right. So let's say we have something like this. And you usually always see them in parentheses because they're individual numbers.
Right. 2.
So always ask yourself, order of operations. Can we do anything inside the parentheses? No. No. So are there any coefficients? No. You don't have to distribute anything.
No.
So because of that, the first one, we just drop the parentheses.
Mm-hmm.
And since the second one's a positive, it's the same as distributing a +1. The numbers inside there keep whatever signs they have.
Right.
All right. Rule, whenever you get rid of parentheses, always combine like terms,
So it'll be 3 and 6,
which would be,
9,
and then
and then
is
5
it
minus 2.
is it positive or negative?
po-
Why?
Positive.
Why?
I said, wait. You're talking about after 9?
Right. Because we had the 3 and the 9. The 3 and the 6 equals 9.
Right. So that's a positive.
Why is it positive though?
I say it's positive because 5 minus 2 is still a 3i.
Well, because you have opposite signs. 5
Right.
is bigger than 2 and 5 is positive. That's why.
Right. Oh,
Yeah,
okay.
so
Well,
because I'm gonna put negatives in there in a minute, and you
oh,
have to know
okay.
why these rules are. So because
Gotcha.
the signs are opposite, take the sign of the larger and subtract the
The light.
numbers.
Okay, I should word that correctly. The larger sign, the larger one
The
is
sign, yeah,
5.
the sign of the larger number.
Yes, it's 3i. Okay. One minus 5i minus -2 plus 3. So minus 5i minus -2 plus 3i. So 4 minus 2. 4 minus 2 equals to 2.
No. Step by step.
Oh,
Order of operations. Can't do anything inside the parentheses. No.
no,
So is there anything in front of this first one? No.
no.
Right? So it's just drop the parentheses for the first one. What you're really doing here, there's a 1. So 1 times 4 is 4. 1 times -5 is -5. That's what you're really
Right.
doing. But now in the second one, negative times negative is a positive. 1 times 2 is 2. Negative times positive is a negative. 1 times 3 is 3i. So if you have a negative in front of a parenthesis, it changes the sign of everything inside there.
Gotcha.
So
Oh,
if it used to be a
negative.
-2, it's +2. It used to be +3, it's now a -3. That's what a negative in front of a parenthesis does.
Gotcha.
Now combine like terms. 4 plus 2,
6. 6, and then it's -5 minus, well, basically plus 3 is 8, -8, right?
yeah, because they're both negative, so the answer is negative. 5 plus 3 is 8.
Gotcha. That's where I screw up too then. And does that always a factor in every like kind of like equation? Is there's there's always that one in front of the parenthesis?
Yes. If there's always a like right now, I'm gonna give you now a bunch of numbers that have coefficients.
Okay. -2, -3, 5i, -3, 7 minus 2i.
Because if you physically see a number there, it's easy. You know what to do now.
Right.
But if there's nothing there, there's always a number 1 in front of everything. There has to be a number. There's always a 1
Okay, so always. Oh, I'm gonna write that down. Always a 1
in front of the parentheses,
in
right?
front of parentheses. Got it. Okay.
Because
So
that one exists everywhere. Even if I had something like 4 plus 2 over 3, add fractions. Well, this is a fraction. Is this a fraction? Yeah, it's over 1.
over 1.
So,
Gotcha.
right? So
Yep.
we can't do anything inside, so we have to get rid of the parentheses.
Mm-hmm.
Negative times negative is a positive.
Is a positive.
2 times 3,
Is 6.
6. Negative times positive,
Is a negative.
2 times 5,
10.
I.
10i. And then a negative and a positive. It's still a negative.
Mhm.
21.
Very good.
And then negative and negative is a positive.
Mhm.
So 6 plus 6i.
Very good.
So then you combine like terms. So 6 minus 21, that's was that negative 15?
Right.
What is it?
21 is bigger, it's negative.
Negative.
21 minus 6 is 15.
Negative 15, and then it's negative, what is that? Negative 4.
Negative 4 what?
I.
Right, yes. Because 10 is bigger than 6, it's negative. 10 minus 6 is 4. I. See, if you break it down in two simple parts, it's much easier because we know how to do 10 minus 6, that's 4. But if you try to do negative 10 plus positive 6, it gets cumbersome.
Yeah.
So just separate the signs from the numbers.
Mm-hmm.
So that's addition and subtraction of complex numbers. Now we go to multiplication. Multiplication of complex numbers. To do this, distributivity rule, more so, it's a method called the FOIL method.
Foil.
Mm-hmm.
Foil.
Have you ever heard of FOIL before?
No.
Okay, so the FOIL method, let's say we just had like 2 plus x and 5 minus x. FOIL is an acronym. The F stands for first.
Okay.
We'll multiply the first numbers. 2 times 5 is 10.
10.
Since they're the first ones in the parentheses.
Mm-hmm.
The O is outer. So the outer numbers.
Which is the
Positive times negative is negative. 2 times x is 2x. So it's the outer numbers.
okay.
I stands for inner. The inner numbers are these two. So this is the F O I. So they're both positive. 5 times x is 5x. And the L stands for last. It's the last numbers inside the parentheses. There's
Which
the L.
is X.
Positive times negative is negative. X
Gotta
times
rewrite
x
that.
is x squared.
I gotta rewrite that because I was all bunching it up and it doesn't look right.
I know what you're talking about because those lines everywhere can easily get
Yeah.
crunched.
So it's 2 plus x, 5 minus x, and then your first line was 2 to 5, which was 10. And then which was the outer to the 2 to x. So that was F O minus 2x. And then it went from 5x.
Then the inner one.
To, okay. Okay. Gotcha.
So there's the FOIL. Actually, I'm gonna start introducing it this way whenever I introduce the FOIL method.
Yeah, I mean, it's a lot neater.
Reason I don't like, I don't know if you watch a cooking channel. There's a chef on the cooking channel named Alton Brown, and he hates to use a tool that's only good for one thing. It's called a unitasker. So FOIL method is a unitasker. It only works if you have a binomial
Oh, wait.
times a binomial. In other words, two terms
Bless you.
times two terms. That's the only time the FOIL method works. Anything else, if one of them or both of them are bigger or smaller, then we cannot use the FOIL method.
Gotcha.
So the FOIL method only works in this case. That's why I like to teach the distributivity, because what you're
Mhm.
really doing is you're taking this whole first parenthesis and you're multiplying it to both of those numbers. But I don't want to get you confused.
Yeah.
But yeah, this
But
only
I
works.
see what you're saying.
Well, actually,
Yeah,
let me show
I
you,
can-
because since I got your brain confused already, let me get it unconfused. So
Okay.
the FOIL method, remember the FOIL method was this, a distributive method. I
It
should
goes
say.
from 2. Okay.
Okay, so
X plus Y.
yeah, so
and X
whatever's in
plus-
front,
yeah,
you multiply it to everything inside there.
Right. So you go
So
to the X and the Y.
yeah, so this is the A, this is the X plus Y.
Okay, so X plus Y, and this is A.
So whatever this first is, I multiply it to 5. So 5, 2
Mhm.
plus X.
2 plus. Gotcha.
Then I have the minus X times 2 plus X.
Gotcha.
Now I distribute again. 5 times 2 is 10.
10,
5 times X is 5X.
and then negative 2X.
Negative 2X.
2X, and then X squared.
Negative X squared.
Oh, negative X squared.
Yeah, so
Gotcha.
negative times positive is negative. X times X is X squared.
Mhm.
That's why I always do it in 2 steps. Do the signs first, then the numbers.
Gotcha.
Then combine like terms.
Okay, I see it now. I see it.
Yeah. So this way here, even if I had 3 numbers or 4 or 5 numbers, this method would always work.
Gotcha.
So,
Yeah.
but people coming back from high school say, oh, I remember the FOIL method. That's all I remember from high school math is FOIL.
I
But it
never
only
learned
works on this.
it.
So
I never
it's
learned
use
that
whatever's
in school.
easiest for you to remember. As long as you basically multiply everything in the first times everything in the second.
Right. Gotcha.
So we know we have how many terms in this one in our answer here so far? 1, 2, 3, 4. Yeah, because there's 2 terms times 2 terms equals 4 terms.
Mhm.
There's 2 terms here. 1, 2, 1, 2.
Right.
If I multiply them together, I should have 4 terms. 1, 2, 3, 4.
Right.
So if I had 2 terms and 3 terms, I should have how many here?
4 terms and 3 terms.
Now, if I had 2 terms, if I had A plus B,
A plus
X
B.
plus Y plus Z. If I
That's
multiply these together, how many terms should I have when I multiply them?
5.
2
Right. Am I
times
not doing that right? Oh, 2
2
times. So it'll be
3.
like 1. Gotcha.
2
6.
times, there's 2 terms times 3 terms. I'll have 6 terms.
Gotcha. Okay, I did that wrong. But now I see now. It's AB, which is 2 right there, and then there's 1, 2, 3, and then
Right.
multiply it because it was parentheses. Got
Yeah,
it.
because I had AB here, CD, 2 times 2 is 4. Now I
Gotcha.
combine like terms. 5 minus 2x is a positive 3x
3x,
minus x squared.
and then minus x squared. Gotcha.
So far, so good?
Yep.
All right, so now let's do this with imaginary numbers.
Ooh, okay.
2 plus 3i,
2
4
plus
plus 5i.
and then 4 plus 5x. Okay. So do you do that FOIL method for this? Because it
Mhm.
seems pretty.
Yep.
Okay, so it's, let me look at these notes. Okay, so it goes to the first one, goes to 4, and then it goes to 5. So
Mhm.
2 times 4, 8, and then it's plus 10. Would you put 10i,
Right? Mhm.
right? Okay. And then you bring the number, what was the shit. Okay, the x, right? Now you gotta do the 3, right?
Right.
And then you do this. It sounds kind of crazy, but does it matter like which number goes first, or does it? Or you just do it to the first one and then to the second?
Right. So basically, this first number, the 2, has to go to both of those. Then the
Right.
3i has to go to both of those.
Okay. So it'll be, you're multiplying, so it's 12 plus
Positive plus 12.
12. Do you make it an I?
I have to, yeah, because it's 3i times 4.
Yeah, so it's an I.
Mhm.
And then 15 I
Sine
plus 15
plus 59, right? What is I times I? I
Oh,
times I,
it's a square. Sorry.
right? Yeah, because
Plus
yeah,
15.
now it's more so important than anything because remember what it was combined like terms?
Right. And then now we do a plus 22i
Mm-hmm.
plus 15 square, or I square.
But remember what I said earlier,
Uh-huh. You gotta come.
I cannot have an
Oh yeah,
exponent.
I cannot have an exponent.
So what do we do with I squared?
Wait, I don't know. I know I wrote it down, but I don't know where I wrote that down.
Well,
Uh,
only thing we know so far is I equals square root of -1. That's when we first introduced imaginary numbers. I
Oh,
is a
yeah.
square.
Yeah.
So how do we get I squared? If we square both sides. So I squared, the square root and the square cancel. So I squared equals -1. There's your second
Okay.
formula. Anywhere you see an I squared, just replace it with a -1.
I squared equals -1.
So we have 8 plus 22i plus 15, I squared, making a -1.
Oh, okay. Okay.
So I squared becomes -1.
Gotcha.
So positive times a negative is a negative. 15 times 1 is 15.
Right. Okay.
Follow that so far.
Oh, minus 15, minus 15. I wrote
Because
that
remember,
wrong.
always
Minus 15.
always whenever you do
Always
multiplication,
do.
I want to start hearing that from now on. You do before I hear 15 times 1, I want to hear positive times positive or negative. Positive times negative is a negative. 15 times
Right.
1 is 15.
Right.
Because
There's
again,
positive and negative.
it's positive. They're different than the numbers.
Right.
Now we combine like terms.
So 8 minus, well, whatever, 8 minus 15. So it's right. I did that. I mean,
Yeah.
8 plus 15.
So
8
no,
and 15.
is it positive or negative first?
Positive 8 and negative 15. And then that equals to,
Is it positive or negative?
it's going to be a negative. It's going to be a negative,
Negative what?
negative 7. Wait,
Right. Negative 7.
7,
Because 15 is bigger than 8, so it's negative. 15 minus 8 is 7.
7. So, and it's negative 7 plus 22i.
Yep. Now we're back to complex numbers. You're done. You just cannot have an
Got
I
it.
squared.
Right. I'm
Let's
gonna have
do
to
another one.
practice that negative 1 thing. So it's
Okay, try that one.
positive 3i.
Let's do a negative 5 times negative 3.
Negative 5.
Yeah. I like having negatives now.
I feel so defeated. All right, so we're gonna do 5 on both sides. So it's gonna be negative 5 times positive 3 is 15. Negative 15. And then
Right. So do the negatives first. Before I hear a number, I want to hear positive or negative. So negative times positive is a negative.
oh, negative times
5
positive
times,
is a negative.
right. I'm gonna force it out of you. So 5 times 3 is 15. There. That is the
Yes.
first one.
Okay, and then the second one will be negative, a negative and another negative, which is a positive,
Very
which
good.
is 5 times 4 is plus 20i.
Very good.
And then the next one is going to be 3i, which negative and a positive,
Is
negative
a
is a
right.
negative is a negative, so it's minus 9i.
Very good.
And then the next one would be, it's a negative and a negative, which is a positive,
Very good.
positive 12i square.
Excellent.
Okay, got it.
Excellent.
I gotta start saying my
I guess
math work.
once you
Oh,
get in
yeah.
that habit, your errors of signs will be pretty much gone from here on out. Once you get
Got
used to
it.
doing
Okay. So we're gonna do combine. Wait. Yes, combine like terms, correct?
it. Mm-hmm.
So it's what am I looking at? So we have the negative. Wait, negative 15. So what did you combine? I'm sorry, question. But what did you combine the negative? I mean, positive 20i minus 9i first.
Yes.
Okay. So it's 15, negative 15, and then bigger numbers 20. So 20 minus 9. 11. Wait, 11.
Mhm.
So it's plus 11i plus, oh shoot, 12i square. But there can't be a 12i square. So it is a negative 1.
Right.
All right.
That's why I left it on top of the screen right there.
Gotcha. So it's plus, and
So I squared becomes -1.
All right. And then from there, that equals to shoot, -15 plus 11i negative 12. Wouldn't then you combine the 15 and 12?
Yes.
So 27, -27,
Very good.
negative plus a negative.
Yeah, since the signs are the same, keep the sign and add the numbers.
All right, 27 plus 11i.
So far,
Hey,
so
that
good.
wasn't that bad. Yeah, got it.
Okay, since you're comfortable with that, let me show you a shortcut.
All right.
This I squared thing.
Mhm,
See up here in the first example, we had plus 15i squared.
mhm.
It later became a minus 15i, or negative 15. This one was positive 12i squared, eventually became negative 12.
Right.
So whenever you have an I squared, just get rid of it and change the sign in front of the number.
Gotcha.
That's a shortcut.
Gotcha. So get rid of it. I'm gonna put that on the side. Get
So
rid of it. Change.
drop I squared, change the sign
Drop
of
a
its
square.
coefficient.
Change. Change the sign of coefficient. Got it.
Yeah, so
Hmm.
so far so good. We're
Yep.
almost done. Now
I'm
I'm
I
just
feel pretty comfortable today. And this is so like this is the algebra I like to learn. I am bad at graphs. Horrible.
yeah, because before this, I mean, you always have computers or calculators doing your graphing for you, but you don't need that. Once you understand the transformations, once you understand where the functions come from, the graphing is just connect the dots.
Yeah, I mean, I kind of learned some things. I'm not, that sounds really bad, but like I kind of figured out some things where I was like comfortable. It's like, oh, I know, I get it. But then there's times that
Right.
I'm just like, I did not learn any of this ever. Like even in high school, we never learned any of it. So I was like, wow, I'm at ground zero, learning a lot of it.
Which is perfect. Actually, and I'm so glad to hear that because even though you're shortchanged in high school,
Hmm.
now you're learning math.
Yeah,
And
and it's
that's
so
what
different because I have a little cousin. He's like, hey, you can come over and I can teach you, but he's in high school and he's learning this in high school, and I'm like, I'm 30 years old learning all of this now, and it's so hard.
to be
It's
honest with you,
different.
you first learn
It's
this
not as
stuff.
hard, but it's just
Well,
like all at once.
yes, you're
Yeah,
cramming. They do it in a year. You're doing it in
yeah,
16 weeks,
yeah.
and
So
they
I'm like,
meet 5 days a week. You only meet 2 days a week, so you're only
yeah,
really meeting 8 weeks as opposed to their 32 weeks. So
yeah,
it's four
totally get
times
it.
difference.
Yeah.
Okay, do this one.
All right. All right. So do the full, are we doing this? We're still sticking to the full method. So you got positive and a positive. So that's 3 times 3 is 9. And then you got a positive, oh wait, positive and a negative. 3 times a negative 4 is minus 12i. And then you got 4i times, or positive times a positive. So
Is
it's
positive.
plus 12i. Give me 1 second. I apologize. So you have 9 minus 12i plus 12i,
Right.
minus 16i squared.
Very good. Very good.
So that's where I kind of get those like that issue right there is kind of where I kind of get a little like, because it's you have to combine like terms. Obviously,
Yes.
it's 12i minus 12i negative 12i plus a positive 12i. So is that a 0i?
Yeah.
Why not?
They cancel each
Okay.
other out. They cancel out.
Cancel each other out. Okay. So that's 9 minus 16i squared.
Yeah, because all you have left to do is, but we have an I squared. What do we do with that?
And then you change it to a positive. So plus 16.
Yeah, because you drop the I squared and change the sign.
That's 25.
Very good.
What? Got it. So proud of myself today.
You're doing good. How about this one?
All right. Minus 6i and then negative 2 plus 6i. All right, so negative times a negative, that equals to a positive 4. And then 2 to 6. My negative to the positive is, what did I say? Negative 12i. And then negative 2 of negative is a positive 12i. Then 6 to 6 is a negative. Positive on a negative is a negative 36i squared.
Very good. That's what you just told me to do. Now what?
And then so you combine like terms. So negative and positive, they cancel each other out. So you have 4 plus 36 equals to 40.
Excellent. Excellent. Let's try small ones now.
All right. One plus one minus I. So 1 times 1 equals 1. And then 1 times 1i equals, I mean, a positive and negative. So it'll be a negative 1i.
Yeah.
Is that right? And then you
Yes.
go, so you have 1i, which is a positive 1i to a 1. So it's plus 1i. And then positive to a negative. So you have plus I squared.
Plus I squared.
Wait, no, I mean negative I squared. Sorry, I said that.
There you
I
go.
was still repeating it in my head. Negative I squared. Then these two cancel each other out. So you have 1 drop down 1, but that's a plus. So plus 1 equals to 2.
Very good. Very
Got
good.
it down. Got it down.
Yeah. So now that took you about 5 minutes longer than it should have. I'm gonna show you a shortcut.
Sorry.
No, but I'm gonna show you. I mean, here's a shortcut.
Okay.
Here,
Okay.
I'm gonna give you 6 plus 5i, 6 minus 5i.
Okay. 6. How did you do that?
Prove me wrong first.
Okay, prove me wrong. So I have to go through the whole steps,
Yeah.
right?
Yes.
Okay, so positive 6 times 6 is 36. And then you got positive times a negative is minus 30i. And then you got 5 positive and then positive is, what is that, 35? 35
30,
I,
30i.
and
5
then,
times 6 is 30.
oh yeah, 30, sorry, 30. And then you got 5 times 5 is 25, but it's a negative 25 I square.
Very good.
So you got, these cancel each other out. So you got 36 plus 25, right? That 61. How did you look at it and know though?
Okay, here's the shortcut.
Okay.
The shortcut's this. Whenever you have the same numbers, but the only
Mhm.
thing different are the signs. Let's work this one out. I'll show you what the formula is going to be. So positive times positive is positive. A times A is A squared. Positive times negative is a negative. A times BI is A BI. That's this one. Positive times positive is a positive. A times BI is a BI. Positive times negative is a negative. BI times BI is B squared I squared. So far, so good.
Yeah.
I didn't sound too confident.
No, I was like trying to move my mouth and it's actually your mouth. So, okay, so you got, okay, so ABI and ABI,
They cancel.
they cancel each other out. Hi. Hello, how y'all doing today? Thank you. I got y'all both. Thank you. Good morning. Yes, ma'am. Oh, yes, ma'am. If I can get you to sign this guideline for me, please, so your membership can still be free. Thank you. All right, and then it equals to a square,
This is 10,
18.
18.
Thank you. You can leave it there. You just signed the guidelines that you're of age for a senior of age, so you can get your membership free still. It's I promise you, you didn't sign a life or death will. Thank you. So, all right, I'm back. So a square, it's minus b square I square.
Right.
So you add those.
No. What do you do with I
Put them,
squared?
combine them. Combine them.
No.
You combine.
What is I
Well,
squared? Drop that. Change the sign up in front of it.
right to positive. I mean, well, opposite.
Just change the sign of the coefficient. So if you have A plus BI times A minus BI, you just square these two numbers and add them together.
Oh.
Look at here. The first one we did. What's 3 squared?
Wait, ask that again. Oh,
The first one, we had numbers 3 and 4. It doesn't matter what signs are because the squares cancel them out. So we have 3 and 4.
right.
What's 3 squared?
9.
4 squared?
Shit. 4 times 4. 4. I'm like, whoa. It's 4 times 4 is 16.
16. 9 plus 16?
9, 16, 17, 18, 25. 25.
25. You did it right earlier. We just skipped all this other stuff.
Oh, okay. I'm getting it.
Same with this one.
So
The first
base,
number is 2. The second number is 6. Square those and add them together.
Square them. So 2 times 2 is 4, and then it was 6 times 6 is 36i.
No, just 36. No, there's no more
Oh,
eyes.
36. No eyes. No more eyes. Just kidding. What? And then it was 4 plus 36 equals 40.
Yeah, so it's 1 squared. The coefficient of I is 1, so it's 1 squared plus 1 squared is 2.
So basically square the first parentheses.
Well, it's just the numbers, yeah. And take one of the
Yeah, just the
parentheses.
numbers. Just
Doesn't matter if they're positive or negative because the squares get rid of those. Just the
Right.
numbers.
mind blowing.
Yeah, 6 squared is 36. 5 squared is 25. So you just skip all this stuff here.
Oh wow.
So that
That
saves
is
you a bunch of
awesome.
time.
Okay. Yeah.
This has a name. Whenever you have the same numbers, different signs,
Mm-hmm.
it's called a complex conjugate. A complex conjugate. The complex
Gotcha.
conjugate is same numbers, different signs. So this is the shortcut whenever you have complex conjugates.
Got it.
Now, there has to be a reason why we introduce something in the complex conjugates. Division of complex numbers. One rule. You cannot have I in the denominator. So that's the only rule we have in division.
Okay.
4i over 3, that's okay. You leave it like that. But if you had 3 over 4i, we're going to look at, first off, we're going to look at monomials denominators. In other words, you only have one number on the bottom. There's no plus minus on the bottom. So if you have a monomial on the denominator,
Mm-hmm.
just multiply the top and bottom by I. Because what is I divided by I? Anything divided by itself is
1.
1. Yeah. So all I'm doing is multiplying by 1. So 3 times I is 3i. 4 times I is 4i squared.
4i squared.
Remember, the I squared changes the sign of
Changes
the
sign to-
coefficient.
Which would be a -4.
Right. And since we don't like to have negatives on the bottom, either move it out in front or on top. Doesn't matter where.
Got it. -3i 4.
How about that one?
-5 8i. So then you'll just multiply by over equals to -5i
Right.
over -8. But then how does that work out if they're both negative?
Cancel them. It's
Can't
negative
cancel
one
them?
over negative one.
Oh. Cancel them.
Yeah, it's like negative one over negative one. They can both cancel. All right, do
Okay,
this
so
one.
I had 5i and then it equals to 3i over 5.
No,
Could
no,
you
no. This
simplify
is a whole
it?
new question. This is the final answer,
Oh,
5i over 8. Yeah.
no,
Once
okay,
you
then
get
why
rid of
were
the
you
I squared,
simplifying?
yeah, once you get rid of the I squared at the
Gotcha.
bottom,
Gotcha. Okay. So our new problem is
3i over 5.
3i over 5. And then you times it times I. So you got, wait, I lost myself all of a sudden. So would it be 3, a positive 3i square over 5i? What?
You
How
only,
is that done?
because only
Oh, it's
if it's I
already
on the
on top.
bottom, it's already on top.
Yeah, it's already on top. Now I was looking at it. I was like, yeah, that doesn't seem right.
It's even
Oh,
right here.
okay. Okay, so that's done. I was already on top.
Yeah. This is what's called, when you get rid of the I on the bottom, it's
Yeah.
called rationalizing the denominator. We're fixing the bottom. Okay, so
Right.
that does it with only one number, monomials on the bottom. Let's look if we have binomials on the bottom.
Okay. This is where it's gonna get very complex. I can see it.
Actually, yes and no, because if you remember what our rule was, our two basic
Right.
rules, then it'll be fixed, no problem.
Gotcha. Plus 2i.
So remember, we cannot have an I on the bottom.
Correct.
So what do we multiply the top and bottom to get rid of the I?
I. Right.
No. If we did that, then we have 4i.
1.
No. Well, it's going to be 1,
No.
but what number goes here? Did this answer have any more i's in it?
No, it did not.
No. So we multiply by the conjugate. We multiply by the complex conjugate.
Yeah.
So
Okay,
all
so
it
we're
is
multiplying. Sorry, I
just
apologize.
multiply by just a change the sign in front of the I.
Okay. Change this sign of the I.
So in this one, we're going to multiply by 4 minus 2i.
So you change, sorry, change sign. Change sign. So it equals to 3 over 4 minus 2i. Correct.
Yeah, so all you do is change the sign in front of the I. So it's 4 plus 2i, multiply 4 minus 2i, top and bottom.
Okay, so I completed that one again. So 4 plus 2i parentheses and then multiply it by 4 minus 2i on top and bottom.
Yeah, but it has to be 1. It's the same number on
Right.
top of each other.
Oh, okay. Yeah. I see what you're saying. I got it. Change. Sorry. The sign of I. Okay.
So we just multiply across now. Positive times positive, 3 times 4 is 12. Positive times negative is negative. 3 times 2 is 6i.
And then do you do the same for the bottom? Would it be like 8? And then it count, oh no,
Remember the shortcut we had?
you're right. It was the same sign. Well, it's the same, so you
If
square
it's
it
the
off.
same numbers, only different signs, then it's just square the two numbers and add them together.
B squared plus B squared. Gotcha.
So 4 squared is 16, 2 squared is 4, 16 plus 4 is 20.
Sixteen plus 4 is 20. Oh, okay. I see.
But
I
we're
see
not
what I
done.
did there because I was so confused.
Are you unconfused now?
Now I am.
So if you look
Here,
at all
ma'am.
these, they're all even numbers.
Can you unlock the? I don't know if it's unlocked. Can you check for me, please? You're good to go. Thanks. Sorry.
So on top, since all these numbers are even, they have to have something in common.
hmm
What does 12 and 6 have in common?
Um, 6. You can divide 6 into 12 2 times.
So it goes in there 2 times there, minus, what's this going to be?
Wait. What? My brain went ahead of
You
myself.
factor
I
out
want
a
to say.
6 out of both of these numbers. You factor out a 6.
hmm
So 12 divided by 6 is 2. 6i divided by 6 is
1.
I. 1i, yeah.
When I.
Over 20. Now what do 6 and 20 have in common?
Two.
2 goes into 6 3
3.
times. 2 goes into 20 10 times.
3. 3. Over 10.
Because
Can you
we
just bring
canceled.
down the parentheses? Oh, okay. We just brought it down and just simplified the 6 that was in front of it.
Yeah, because they have to be
Got
multiplied
it.
before you can simplify.
Right. And that's the answer.
Yeah, I don't know how the computer wants it. If this is not, it doesn't take this,
Uh-huh.
then multiply that 3, so we get 6 minus 3i over 10. It's one of these two, but they're both the same answers. I don't know how the computer wants it. The computer probably wants it in this one since there's less programming.
Okay.
So just
Okay.
get rid of the multiply, distribute, get rid of the parentheses. Let's try another one.
-2. -3 minus 4i. All right. So we change the sign in front of the I.
Mhm.
Is that correct? Okay, so that's a +4.
So what do I multiply by?
You're multiplying by, would that be, okay, so would that be -3 plus 4i?
Yep. On top and bottom.
Gotcha. So, and then that's that's when you, okay, so that's when you -2, my negative times negative is 6. And then it's a +6, and then -2 and some +2, 4 is -8i.
Mm-hmm.
And would it, so would this be over the -3 plus 4i? I'm so freaking
No,
stupid.
you're multiplying these two. You
Just
multiply
a
these
second.
two, multiply these two.
So now I lost myself now again,
Well, you multiplied -2 times that, you got this answer here.
right?
So you're gonna multiply this times this. And what does that give you?
What is it? Because the thing drags. What am I multiplying?
The two bottom numbers,
Oh, I multiplied these together
right?
to each
But
other.
that's, yeah,
Oh, okay,
you're
okay,
multiplying them.
okay, okay. Okay. So -3 and a negative is a +9. And then a positive and a positive is 4. It's plus 16i squared. Is that right? I feel like I'm all wrong. Oh, no I.
Complex conjugates. That's the
Yes,
whole, the
I
bottom number is
forgot.
always gonna be the shortcut.
No I, Taylor. No I on the bottom. Got it. 25. So it's 6 minus 8i. It's over 25.
Right.
Got it.
Okay, now, since you got all those partially right,
Okay, I got it now. I think I got it now. I'm
okay,
ready now.
then do this one.
Okay. Oh,
I now changed the top.
and what?
No longer is, I used to have only one number on top. Now I have an equation on top,
Right.
but it's the process is still the same.
Process still the same.
Mm-hmm.
Okay. So are we? No, I don't understand at this point. So are we multiplying it by the denominator? What it's saying on the denominator? So it's okay. So would it be -5, right? -5. Wait a minute. -2i.
No,
I'm so lost now at this point.
look at your notes. What's the
Okay.
formula?
It is
The complex conjugate formula.
what is it? The a plus bi and then a minus bi. Is it that one?
So what's the only thing that
Equals
changes in those parentheses?
the sign.
What sign?
The negative or positive.
The sign in front of the I. That's the only thing that changes.
Oh, the sign in front of the I.
Yeah, I even put that up here.
Where? I wrote that. I missed. I probably am I writing everything else. Taylor, this is all the whole. Okay, you did write it down. Change it. Okay, so it would be. So the 5 is the same, correct?
Right.
So it's okay. So it's 5 minus 20. I mean 2i.
Very good. Yeah. Even if 5 was a negative, you leave it alone. Just change the sign in front of the I.
Okay. All right. So shoot. Now I lost myself again. All right. So now we do. My brain just went out because I was so lost for a moment, but I got this again. Hold on. It's gonna be so you do the 2 and 5. Is that
Mhm.
right? 10 minus, I mean, negative is plus 6i squared.
You're foiling. You have 2 terms here
Oh,
and 2 terms here.
okay. Okay. So it's 2 minus 2, positive 10, and then 2 and positive times a negative is a negative 4i.
Very good.
And then do you do it for
The
the
inner
bottom
ones.
of the inner ones? Okay, and then you do 3 negative to a positive is negative 15i.
Right.
And then you do negative 3 to a negative, that'll be plus 6i squared.
Very good.
And then
And
it's
what's on the bottom?
over. All right, now I'm a little confused. I know you just gotta, you take the I away, right? So the signs are different.
Yes. What's your shortcut?
So, change the sign, right? Because it's a positive one.
Look at the formula. Highlight this formula somewhere. If you have a highlighter at the office somewhere, highlight this formula. Because this will help you easily just whenever you go back and forth. If you have the same numbers but different sign in the middle, this is the shortcut. So in this case, it's always going on the bottom, it's always going to be the same shortcut. Take the first number, square it.
First
Plus-
number. Oh, okay. Okay, because I'm over here thinking it was just the top, and then you do the second one to square it as well.
Right.
So it's 5 squared plus 2 squared equals 25. 2 times 2 is 4, so it equals to 29.
Right. That's the bottom number. Now you just have to
Got
fix the
it.
top number.
Yeah. So it's 29, and then the top is, we have, what is that, 4? That's 19i, so it's 10 minus 19i, and then do you plus 6i squared.
But what happens to I squared?
You multiply it,
Change
Well,
the
you-
sign.
change the
Of the
sign,
coefficient.
so it's minus 6.
Right.
We have 19i, 10, 10, 5, 5. It's 4 minus 19i
Mm-hmm. Over.
over 29.
That's your answer.
Okay, got it now.
My next class is about to start.
Yeah, I was gonna say
11:31.
next class is about to start. Well, good luck.
Yeah. So anything else, look at the videos I sent out this past weekend and that'll help
Okay.
you.
Gotcha. Thank you
All right.
so much.
Take care.
Have a good day.
You too. Bye.
Bye.